Why is it that when we have a ladder against a smooth wall but rough ground, it stays up and doesn't slide down? But when we have the opposite, rough wall with a smooth ground, it can never be in equilibrium. Let's consider all the forces on a ladder in this situation. We have a rough ground and a smooth wall. Making the assumption that this is a uniform ladder, the weight should act through its center of gravity. There is a horizontal reaction force from the wall, and likewise there is an upward reaction force from the ground. Now imagine the ladder sliding down. If it were to slide, it would do so by turning clockwise. This shows us that the frictional force from the ground must act towards the right. Can this ladder ever be in equilibrium if it's against a smooth wall and rough ground? If the reaction force from the wall balances the ground's friction, then all the horizontal components are balanced. If the reaction from the ground is equal to the weight of the ladder, then all the vertical components are balanced. So yes, it can be in equilibrium. Change it up, we now have a smooth ground with a rough wall. The weight is still acting downwards through the center of gravity. We still have the reaction force from the ground as well as the reaction force from the wall. But this time, we don't have a frictional force from the ground. But instead, the friction comes from the rough wall acting upwards. Can this now be in equilibrium? The vertical components we have are friction from the wall, reaction from the ground, and weight. As for the horizontal force, we only have reaction from the wall. So even if all the vertical forces balance out and we have vertical equilibrium, horizontal equilibrium can never be achieved here because there isn't another force to balance the wall's reaction. So this tells us that no matter how rough the wall is, we can never achieve equilibrium if the ladder is resting on a smooth ground.